Hello everyone. So, I welcome you back in this course, Introduction to Sequence Stratigraphy. My name is Biplab Bhattacharya and I am your instructor. So, in the last class, we have got a very brief introduction about the concept of sequence stratigraphy, and in continuation to that, in the second class, I will try to give you idea about some very basic terminologies which are very frequently used in sequence stratigraphy, and also we will be using those terms very frequently. So, I think that it will be a good idea that at this particular stage we should get acquainted with those basic terminologies which will be coming every now and then, which will be referring every now and then during our discussions in the next classes. So, the common terminologies which are commonly used in sequence stratigraphy are defined in terms of the overall sedimentary package. So, sequence stratigraphy is basically the study of sedimentary packages, and those sedimentary packages are actually reflecting the processes which were going on, particularly the sedimentary processes which were going on in the basin at that particular time, and in response to that, what are the final products. And when I am talking about these processes, they are related to other parameters, other factors, some of them autogenic, some of them allogenic, which result in the base level position and the accommodation condition. What is the accommodation available in that particular basin? The detailed concept of base level, accommodation, what is the relations, all these things we will discuss in detail in later classes. So, what we get is the final product, and those products are commonly defined in terms of different sequence stratigraphic terminologies. So, these terminologies can be identified from individual depositional systems or may be defined across the basin scale. So, the common terms or the most important terms that we commonly use in sequence stratigraphy are definitely the term sequence, because from there the term is coming as sequence stratigraphy, and within the sequence we commonly discuss about systems tract, which is again a very common term. Systems tracts are actually associated with depositional systems, and we deal with the boundaries for the sequence, boundaries for the systems tract. So, these four items or these four terminologies are the most fundamental terminologies used in any sequence stratigraphic study. So, in this class, very briefly we will try to discuss about the basic concepts of these four terminologies. In later classes, we will discuss in more detail. For example, we will have separate class on the types of sequences, and there again we will discuss about sequence, and we will discuss about what are the different types of sequences and what are the implications of them. Similarly, we will have separate classes on different types of systems tracts. So, there we will have more detailed discussions. So, if I look into the definition of sequence stratigraphy, it says that the study of the rock relationships within a time stratigraphic framework. So, basically we are studying the rocks and how these rocks are interrelated within a time stratigraphic framework. When we are talking about the rocks, these are genetically related strata which are bounded by surfaces of erosion or non-deposition or their correlative conformities. So, in sequence stratigraphy, three major parameters are there, three important factors are there. Number one, the rock strata. Number two, the boundaries which are confining this rock strata, and third one, a time connotation to those rock units or maybe the boundaries. When we are talking about the rock strata, they should be genetically related. Such analysis of repetitive genetically related depositional units bounded in part by surfaces of non-deposition or erosion also comes under the study of sequence stratigraphy. So, in sequence stratigraphy, very often we get the occurrence of similar kind of sediment packages repeating in vertical succession. So, their analysis of those cyclic sedimentation patterns which appear repeatedly in the stratigraphic succession in response to the variations in the sediment supply and the space available for the sediment to get accumulated. This means that there are certain repetitions in the processes and the conditions over time. So, definitely certain control factors are working in such way in that particular basin that similar conditions are repeating again and again. The recognition and correlation of the stratigraphic surfaces which is bounding these packages of sediments or the cyclic packages, they represent changes in the depositional trends in the sedimentary rocks. So, we commonly put the boundary at that particular place within rock succession where we get a change in the rock type or change in the cyclic occurrence or change in the appearance of the rock. As in the first class I told you about the stratal stacking pattern, how individual strata are stacked one after another. So, there may be change in the stratal stacking pattern. So, wherever we get change in terms of any of these parameters like the rock properties, rock types or the stratal stacking pattern or the depositional condition, there we can put the boundary. The recognition and correlation of sequence stratigraphic surfaces commonly represent changes in the depositional trends in the sedimentary rocks. Such changes were generated by interplay of sedimentation, erosion and oscillating base level conditions and are commonly determined by the sedimentological analysis and their geometric relationships. So, we start with the basic unit which is called as a depositional system. So, what is a depositional system? It is nothing but the three-dimensional assemblage of process related phases that record major paleogeomorphic elements. So, this definition was given by Galloway in 1989 and also it is referred in the book by Cattaneo 2006, where this particular definition of depositional system is mentioned. Other people like Fisher and McGowan, they defined, which was used in Van Wagner in 1995 to define the depositional system, where they have defined it like a three-dimensional assemblage of lithophases genetically linked by active or modern processes or the inferred or ancient processes and the corresponding environments. So, basically what is depositional system? This is the three-dimensional assemblage of all the phases types, commonly the lithophases types, which are occurring in a particular depositional realm in a particular time. So, during a particular time, maybe you can have a fluvial system and within that fluvial system, we can have several sub-environments like the channel part, like the overbank part, like the horseshoe lake. So, all these areas have their own characteristic depositional conditions, depositional processes at that particular time, and due to those processes a resultant product which is nothing but some sediments will get deposited, will be produced. So, after the end of that particular time frame, what we get is a package of sediment formed at each and every area within that entire depositional environment. So, within the fluvial environment, within the channel part, we will get one type of deposition because there we are getting high energy flow is going on. So, it will carry coarser materials, whereas in the floodplain area, it may be a very low energy condition. So, there we can get fine grained sediments like this. When I am looking into the types of lithophases occurring in all those areas, in all those sub environments at that particular time frame, that assemblage of the phases types together constitute the depositional system, and since it is happening in the fluvial system, I will call this one as a fluvial depositional system. Similarly, we can define a shore depositional system, we can define a tidal flat depositional system. When you go into further higher resolution study, we can interpret, say for example, an intertidal depositional system, a subtidal depositional system, maybe within an estuary we can get inner estuary depositional system, outer estuary depositional system like this. So, basically a depositional system is nothing but the 3D assemblage of the lithophases which are genetically linked with respect to the certain processes which is going on in that particular basin at that particular time frame. So, depositional systems represent the sedimentary product of associated depositional environments. They grade laterally into coeval systems, forming logical associations of paleogeomorphic elements, which we commonly define as systems tract in the frame of sequence stratigraphy. So, what is a systems tract now? This is the linkage of contemporaneous depositional systems forming the subdivision of a sequence. This definition was given by Brown and Fisher in 1977 and is mentioned in Catanianu in his book of 2006. So, the systems tracts, they are nothing but the linkage of contemporaneous depositional systems. In other words, a systems tract includes all the strata which are accumulated across the basin during a particular stage of shoreline shift. This concept was given by Catanianu in his book 2006, which clearly says that during a particular phase of shoreline shift, say shoreline is moving towards the land, which we commonly call as a transgression. So, during that phase, we can get certain changes in the depositional conditions, depositional environments in that particular area. So, the facies architecture formed in different parts of that area will produce different depositional systems. So, all the depositional systems formed during this phase of transgression, during this phase of shoreline shift can be called as one systems tract. So, we can take one example over here. Say you have a basin section, marginal marine part, where this is the sea level condition. Now, there is a sea level rise, and due to that rise, it is a transgression is happening now. So, definitely what is happening over here, the shallow marine part is extended and we will get some shallow marine deposits going on over here during this phase of transgression. Beyond that, we will have the fluvial part, fluvial system is going on. And if I go down over here, in this portion we can have the self depositional system, and maybe somewhere here we can have the slope or the deep basinal depositional system. So, when I am saying a self depositional system, I am considering all the facies types which are occurring in that self at that particular time in response to the processes which are going on in that particular basin. So, if you think of in a 3-dimensional way, just think of a 3D basin where you have a self, and in that self suddenly the water level has risen up. So, the energy condition has changed, and due to that change in an energy condition, we are getting some other type of facies coming up over here getting deposited during this particular phase. So, all the types of assemblages of facies will produce distinct depositional systems in different parts of the basin. We will get a fluvial depositional system over here, we will get a shore depositional system over here, a self depositional system over here, and a slope depositional system over here. Now, if after this the sea level starts falling, the transgression will stop. That means the shift of the shoreline towards the land is stopped and it will move in the reverse direction. So, as per this definition of systems tract, this will be the end when this turnover will start. Turnover in terms of change in sea level and turnover in terms of the shift of the shoreline will start. At that particular moment, the depositional packages will be phrased to define a systems tract. So, now during this phase of transgression, whatever packages have formed in terms of 3D facies assemblage. So, we get the fluvial depositional system, shore depositional system, self depositional system and slope depositional system. All these together will produce a transgressive systems tract. In brief, we call it as TST, transgressive systems tract. So, a systems tract is actually developing across the entire basin in response to the processes going on during a particular phase of shoreline shift. But the response will be different in different parts because the conditions, the energy level, the sediment supply are different in different parts of the basin. So, definitely the shore area, the shore depositional system, its facies types, and the slope depositional system, its facies types will be completely different. But irrespective of that difference, since they are genetically related, here when I am saying genetically related, that means they are forming under the same phase of Soldein shift. So, they can be considered or they will be identified as part of the single systems tract. Maybe in this case it is an example of a transgressive systems tract. So, systems tracts are interpreted based on stratal stacking patterns, position within the sequence and the types of bounding surfaces. So, bounding surfaces can be for the sequence as well as it can be for the systems tracts. The timing of the systems tracts is inferred relative to a curve that describes the base level fluctuations at the shoreline. We will discuss about that particular curve. There are basically two curves are available, which we will discuss to define the base level changes and the transgression regression events, and depending on that we can define different systems tract within a sequence. So, that we will discuss on a later class. Now, coming to the third part, the definition of sequence. So, the initial definition given by Mitchum in 1977, it says that a sequence is a relatively conformable succession of genetically related strata which is bounded by unconformities or their correlative conformities. Later on, this definition was further modified as the subject has gradually evolved. This definition has further modified and nowadays we follow this particular definition, which says that a sequence is a succession of genetically related strata that can be delineated chronologically and spatially and which possesses some characteristic property that defines the sequence as a particular product of the total geological history with respect to events and processes. So, this is a complete definition of sequence followed today, and in this definition these green highlighted portions, they are the key points, they are the important parameters, factors which actually defines a sequence. So, basically a sequence is nothing but a rock strata. Now, we are trying to impart additional criteria. So, it should be a genetically related strata, it should be a conformable strata and it can be correlated or delineated across time and space. And not only that, that strata should bear some characteristic property which will help us to identify that package from other packages which are overlying or underlying. And when we are assigning some characteristic property, so that definitely points to that there should be certain particular processes, events which will be responsible for the formation of that particular package, which will be going on in that particular basin or during that particular geological time. So, these individual highlighted portions can be explained little bit in more detail. So, we can start with the first term, what we mean by this genetically related strata. So, this is the succession of strata which is deposited during one set of external or we can say the allogenic and the internal or the autogenic factors. For example, rising or falling base level condition. For the time being, you can remove the base level term and we can consider sea level. So, rising or falling sea level conditions. Type of sediment availability, it can be same type of sediment, it can be different type of sediment, how much of sediment is coming up. So, that can be another major factor that will define the nature of the strata, nature of the package which will be forming. Same range and type of transporting and depositional energy conditions. This is a very important parameter because energy is the main control factor for everything. So, if the energy condition is high, we will get texturally evolved, texturally matured sediments. If the energy condition is less, we will get more unstable minerals, more finer grain sediments and relatively less matured, texturally matured sediments available over there. And based on all these, what are the type of depositional environments. So, all these factors together constitute a strata, and since those strata are forming under the control of these factors, we can call them as genetically related strata. Or in other words, in the definition of sequence, when we are using the term genetically related strata, what we expect is the strata should have followed or formed by any of these parameters. The second highlighted portion, the strata can be delineated chronologically and spatially. So, that means there should be some kind of lateral and vertical time distribution, where we can trace it laterally as well as in vertical succession it can have a prominent presence, and any changeover will be demarcated by a surface. So, we need some kind of surface that is of the same age or approximately of the same age throughout the whole area, which will help us to demarcate that strata. So, across that surface we will get a changeover in those genetically related strata. So, that means those factors which we have discussed under the genetically related strata, maybe all of them, maybe some of them are changed across that surface, producing a different type of strata or different type of stratal package. So, under this parameter, what are the common factors, common parameters we expect when we looking at this delineated chronologically and spatially? So, it can be a biostratigraphically defined surface, that means there can be change in the fossil assemblages or types of fossil across that particular surface. Stratigraphic surface of same depositional age, seismic surface supposed to represent a depositional surface. Now, if we look into the third parameter, some characteristic properties within that genetically related strata. So, there we can expect similar sedimentary facies association, similar biofacies association. Also, we can get similar kind of surfaces above and below. For example, we can get package defined above and below by subaerial unconformity. Maybe the surfaces are bounded by a transgressive surface, maybe they are bounded by a maximum flooding surface or raffinement surface. So, these three terminologies at the end, at the last part, these are certain sequence stratigraphic terminology. These are different type of surfaces we try to recognize, identify within sedimentary packages, and I am not going to the detail of these particular surfaces. I am not going to that detail today because it requires detailed discussion and that we will do later on. So, basically what we are trying to mean over here is when we are talking about the genetically related strata having some characteristic property, so they can have some common facies association. When I am saying facies association, definitely is the lithofacies or sedimentary facies. We can have similar biofacies association and they can be confined by similar kind of boundaries both below and above. And now into the final part of the definition, which says the particular product of total geological history with respect to events and processes. So, it means that the sequence tells us about an event or episode in the infill history of a basin, which may be formed in response to an episode of fall or rise in the sea level, maybe some tectonic processes, tectonic events which are going on in that particular basin, maybe some climatic changes or maybe some major climatic events, or maybe a change in the nature of sediment accumulation or other environmental characteristics. So, all these factors, if they are acting in that particular basin, whether together or alone, they will change the depositional process. And once the depositional process is changed, that means the energy condition is changed, the flow dynamics is changed, the type of sediments carried will be changed, the type of sediments deposited will be changed, and so the final response is different. So, response is the final product. So, that is the strata that has formed after that particular phase of time. So, when we are talking about a genetically related strata, they should have formed under continuous phase, a constant phase of these parameters, where these parameters are acting together in a coherent way, producing a unique condition. If any one of these is changed, the condition will change and we will get different package, different genetically related strata, where again the factors, the parameters are different. So, it is a kind of interpretation looking at the product. We are looking at the product, we are looking at the rock strata, and from there we are trying to interpret or understand all these aspects, and once these aspects are clear to us, we can define this one as a sequence which is bounded by a very defined surface, and within those surfaces, upper and lower surfaces, what we get is a package which is genetically related and bearing certain characteristic properties. So, we will discuss about the sequence in more detail in later classes, where we will look into the variations and the changes that we commonly get in terms of change in these different conditions, different parameters or factors. So, at the end, before I conclude, I should talk about the boundaries as well. However, we will talk about boundaries in more detail in later classes. But boundaries are very important in sequence stratigraphy, because sequences as well as the system's tracts, they are bounded by distinct surfaces. And whenever we have a sequence stratigraphic surface or sequence stratigraphic boundary, that definitely signifies a specific event or a change in the specific event during the depositional history of the basin. So, such surfaces are very commonly unconformable, but they can also be conformable. So, unconformable means there is a break in the sedimentation, and after the break, when again the sedimentation resumes, we get a completely different package of strata, a completely different genetically related strata. Or on the other hand, when it is a conformable part, we can get a continuous succession. There is no break, no gap in sedimentation, there is no erosion going on. We are getting a continuous succession, but within that continuous succession, there is a change in the process, there is a change in the stratal stacking pattern, there is a change in the genetically related strata. So, that boundary, it can be conformable or it can be unconformable and can mark changes in the sedimentation regime across that particular boundary. So, basically what we have discussed today are some basic terminologies, which starts with depositional system, which is the most primary fundamental unit in sequence stratigraphy. So, this term depositional system is a very general notional term which is defined on the basis of depositional setting and the environment. So, it is not like a very standard term. We do not define depositional system in a very standard way, but it is a very common terminology used in sequence stratigraphy. Apart from this depositional system, we have discussed about the systems tracts and the sequence. So, systems tracts are formed by the depositional system, amalgamation of depositional system, several depositional system together forms a systems tract, and several systems tract produces one sequence. This term systems tract and sequence, they are specific sequence stratigraphic terminologies, which are commonly defined in relation to base level change and the transgressive regressive curve. So, that we will discuss later on, that what are those curves, what are the nature of those curves, and with respect to those curves, how can we define different systems tracts and sequence. Commonly, a systems tract includes a sum of laterally correlative depositional systems, and that is why we commonly use in the term systems tract that S, systems is used, that indicates it is assemblage of several depositional systems. Commonly, a sequence includes at least two systems tracts or maybe more systems tracts. Only one systems tract cannot produce a sequence. A sequence should have at least two or more systems tracts, depending on in which scale, in which order we are trying to study. So, that is all for today for this particular class. So, with this basic knowledge, we will move on to the next class, and there we will discuss about the other fundamental parts of sequence stratigraphy. So, these are some of the references or books for your reference. Thank you everybody.